In this module, we are going to check how to use the inverse trigonometric functions formulae to calculate the derivative of a function. Now, I will discuss each formulae by formulae. We need both inverse trigonometric functions formulae as well as trigonometric function formulae. So, according to the formulae, the problems are created. So, we will learn the formulae and then use the to apply in derivative. Second point to remember is, at the end of this module, you will not only learn how to differentiate inverse trigonometric function, but also you will revise the complete in a trigonometric formulae, which are applied in this each and every problem of this particular module. Okay, first we know that if I write cosec inverse x is nothing but sine inverse 1 by x. So whenever cosec inverse is given, you know that majority of our formulas are in sine, cos and tan. So if cosec inverse is given, you should convert it to sine inverse by taking the reciprocal. Just have a look at this. I want to calculate derivative of cosec inverse 1 upon x square. One method is I can apply directly cosec inverse u formula. Instead, if you apply this formula which you have learned just now, sine inverse of what happens to x, it becomes a reciprocal. What happens to 1 by x square? It becomes x square. Now it is easy for us to differentiate 1 upon root of 1 minus x square the whole square into derivative of x square. So your answer became 2x upon root of 1 minus x raised to 4. So this is a benefit. Whenever we come across cosec inverse, convert it to sine inverse by taking the reciprocal. It is easy to apply derivative sine inverse formula, which is very compact formula, whereas cosec inverse is minus 1 upon modulus of x root x square minus 1. So it's a complicated formula. We have this simple. So whenever you come across cosec inverse x, convert it to sine inverse. Whenever you come across sec inverse x, convert it into cos inverse. And whenever you come across cot inverse x, convert it into tan inverse x by taking the reciprocal of whatever inside the bracket. This is the first application of inverse functions, first set of formula. Second set of formula that I'm going to apply is when there is a negative sign. Suppose I have sine inverse of minus x. It's not so good to have always minus. If you come across any time a minus sign, you can remove the minus outside. If you come across a minus sign in cos, it is not minus cos inverse, is pi minus cos inverse x. You will understand this, that when I write cos inverse of x, this is a number lying between 0 to pi. So if I write cos inverse of minus half, it should be an angle between 0 and pi. By chance, I use this formula. So what will happen? It will become cos inverse of 1 by 2. What will happen to cos inverse of 1 by 2? Minus 60 degrees, which is not belonging to 0 to 180. So this is wrong. Suppose I have used cos inverse of minus formula, pi minus cos inverse x. If I use this way, you will notice that pi minus pi by 3 becomes your answer, 2 pi by 3, which is certainly a number between 0 and pi. So whenever you have cos inverse of minus x, even cot inverse of minus x, you will have pi minus cos inverse x. I'm not going to discuss cosec inverse, sec inverse and cot inverse, because whenever you come across this, convert it into sine inverse, cos inverse and tan inverse and apply this formula. Same way, tan inverse of minus x is minus tan inverse x. So because both of them's range lie between minus pi by 2 and plus pi by 2, both of them, hence minus just comes outside, minus pi by 2 to pi by 2. So when there is a negative sign, just you have to bring the negative outside, automatically it will come between this range. If x happen to be a positive number and minus tan inverse of minus half, so minus tan inverse half, it will come inside between these two. So automatically it will take care. But in cos inverse, it is 0 to pi, that's why it is pi minus cos inverse x. So this is to be remembered. So when there is a negative sign, what to do? Same thing is applicable for cosec inverse x, same thing is applicable for cot inverse x, and the same thing is applicable for sec inverse x. So I'm not discussing those. So automatically, whenever you come across this, just convert it. Cosec inverse converted to sine inverse, cot inverse converted to tan inverse, and sec inverse converted to cos inverse by taking the reciprocal and then apply the formula. So basically, I need to discuss today only three functions: sine inverse, cos inverse, and tan inverse. Others all you will take reciprocal and bring them back. Okay, now we come to the most important formula where we are going to apply the maximum number of times. The formula that we are going to apply is sine inverse of sine theta is theta. Of course, there's a restriction on that. That means whenever you come across sine inverse sine, they can be cancelled. Now, there's a restriction on this. Every time you cannot use this formula. Restriction is like this. This theta should lie between minus pi by 2 and plus pi by 2. Then only you can apply sine inverse of sine theta is theta. Let's have a look at it. Let me say sine inverse of sine 30 degrees. That became sine inverse of 1 by 2. And you know sine inverse of 1 by 2 is 30. So the cancellation rule is applicable. Let's try sine inverse of sine 150 degrees. You know that sine 150 is half. Now, sine inverse of 1 by 2 cannot be written as 150 because theta should lie between minus 90 and plus 90. You know that sine inverse x always lies between minus 90 degrees and plus 90 degrees. So, you cannot have 150 here, you have to have 30 degrees again. So, here the cancellation rule is not applicable. So, you must understand this. Sine inverse of sine theta, this cancellation rule is applicable only from minus pi by 2 to pi by 2. You cannot apply in other day. But as far as functions are concerned, we are going to apply everywhere sine inverse of sine theta as theta whenever, even if the range is not given to you. If the range is given to you, then we'll have to change the formula accordingly, which we will discuss in inverse trigonometric function. Okay, same way, cos inverse of cos theta is theta 0 less than equal to theta less than equal to pi. Tan inverse of tan theta is equal to theta if minus pi by 2 less than theta less than pi by 2. So this cancellation rules are the most important rule that we'll be applying to simplify inverse trigonometric function. So what are we going to do in this chapter? We are going to simplify inverse trigonometric function and then find the derivative. Now I'll give you the first example. Before we go to the example, some trigonometric functions formulae, just let's recap it. So first inverse trigonometric formula that I want to talk to you is sine 2 theta's formula. What is sine 2 theta's formula? 2 sine theta cos theta. How you got this? How you got this formula? Sine of theta plus theta. We expanded sine A plus B's formula and we got that formula. We also know another formula 2 tan theta upon 1 plus tan square theta. These are the two formulae in sine 2 theta. Then cos 2 theta. Cos square theta minus sine square theta, 2 cos square theta minus 1, 1 minus 2 sine square theta, 1 minus tan square theta upon 1 plus tan square theta. Then we have sine 3 theta, 3 sine theta minus 4 sine cube theta. Then we have cos 3 theta, 4 cos cube theta minus 3 cos theta. These are the formulas in sine and cos which we need to remember. Then we also need to remember tan 2 theta's formula. 2 tan theta upon 1 minus tan square theta. You can notice the difference here. Here 1 plus, whereas here 1 minus. Then tan 3 theta, 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. These many formulae we require today to do the problem. I'll show you the first one important thing. Suppose I have sine inverse cos x. Previously I told you sine inverse sine can be cancelled. But if you have sine inverse cos x, what to do? If you have sine inverse cos x, you will write it as sine inverse cos theta is sine pi by 2 minus theta. Which formula did I apply? Sine in cos theta is sine 90 minus theta. Then standard formula. Now sine inverse and sine get cancelled. So you get pi by 2 minus x. Now you can differentiate with respect to x. Differentiating with respect to x, dy by dx will be derivative of pi by 2 which will be 0 and derivative of x which will be 1. So your answer became 0 minus 1. So minus 1 becomes your answer. So you don't have to do sine inverse u method. You could have also done by this method. Derivative sine inverse u. 1 by root 1 minus u square into derivative of u. This method can be applied. You'll come to the same answer. But this you can do it mentally. many of the steps can be converted. So that's why I told you, when outside is sine inverse, even if you have cos, it can be cancelled by changing the angle to 90 minus theta, pi by 2 minus x. So this is an important point to note. Same way, if you have cos inverse, cos x, we can apply the same technique. Tan inverse, cot, also we can apply the same technique. Let's have a look at this. Suppose I have tan inverse of cot x. I can write the same formula, tan inverse of tan, pi by 2 minus x. And then tan inverse tan will get cancelled, pi by 2 minus x. Differentiate it, you will get minus 1 as your answer. So everywhere, if outside is tan inverse, inside is cot, you can make it into tan and then do the cancellation. If outside is sine inverse, inside is cos, you can make the cancellation. Outside is cos inverse, inside is sine, then also you can make the cancellation. So by changing the angles. So this is the point to remember. Now let's have a look at my first problem. Imagine I have a question like this. Y is equal to cos inverse 2 sine 3x cos 3x. Suppose I have been given this form problem. Find the derivative, find dy by dx. Find dy by dx. What do you do is, how will we simplify this? Immediately your mind should work on this formula. 2 sine theta cos theta is sine 2 theta. Remember, in sine and cos, you need to remember only this many formula. You need to identify every time in inverse function how you can convert this into cos by using this formula. So we can write this as cos inverse of sine, look at the angle here, theta. What is the answer angle? 2 theta. So what is the angle here? 3x. So what will be the answer here? 6x, double. Now cos inverse sine cannot be cancelled, but we know what to do for that. So cos inverse cos of pi by 2 minus 6x. So cos inverse cos got cancelled, so pi by 2 minus 6x. And the derivative of this dy by dx will be 0 minus 6 into 1. So your answer is minus 6. So this is a technique we have to apply. You will be given one or other formula which you can identify with the formula given to you. Another example I would like to give you is little more interesting. Let's say I have given you y is equal to cos inverse of 2 tan 3x upon 1 plus tan square 3x. So this will become cos inverse of, this is identified with this formula. So I can write sine, angle is 3x here, angle is theta here. So in the final answer, angle doubles, so 6x. Which I can write as cos inverse of cos pi by 2 minus 6x. Now cos inverse cos will get cancelled, so pi by 2 minus 6x. So dy by dx will become 0 minus 6 into 1, so we'll give you minus 6 as answer. Now let me come to more interesting question. Let's have a look at this next problem. Y is equal to sine inverse of, let's say, 2x upon 1 plus x square. Absolutely, there is no trigonometry in it. So there is no question of sine inverse and sine getting cancelled. But by using a small substitution instead of x, this can be simplified. This is the most important part of this chapter, this exercise. So if you compare this with this, you can understand that in place of x, if I have tan theta, this can be simplified. So my method is put x equal to tan theta. Now I have put a new variable theta, but before derivative, I have to bring it back to x because I want to find dy by dx. So what I'll do is, theta is tan inverse of x. So in the last step, before derivative, I'll replace theta by tan inverse x. So what happens here? Y is equal to sine inverse 2 tan theta upon 1 plus tan square theta. So that became sine inverse of sine 2 theta. That is from this formula. That became 2 theta. That became 2 theta is nothing but tan inverse x. So I have brought it back. So what have you proved? This complicated function is such a simple function. And you know how to differentiate this. So dy by dx will be 2 into derivative of tan inverse x. In the last session, we learned the formula for derivative tan inverse x. So 2 into 1 upon 1 plus x square. So your answer became 2 upon 1 plus x square. This is how we can calculate this. Now let's have a look at another little more complicated one. Let's say I'm going to give you cos inverse of 2 raised to minus x minus 2 raised to x upon 2 raised to x plus 2 raised to x. 2 raised to minus x plus x. So now we do not have any formula which is similar to it, but I see something similarity here. There is the opposite sign, some possibility of matching here. So first of all, there are two different functions. They are functions, some are in 2 raised to minus x, some are in 2 raised to x. First step that you must do is make it in one variable, one function. So I will write this as cos inverse 1 by 2 raised to x minus 2 raised to x upon 1 by 2 raised to x plus 2 raised to x. So that when I take the LCM, 1 minus 2 raised to x the whole square upon 1 plus 2 raised to x the whole square. Now this can be compared with this formula. So in place of 2 raised to x, what should I have? In place of 2 raised to x, if you compare it, I should have 2 raised to x to be tan theta. If I put 2 raised to x as tan theta, this function will turn up to be cos inverse of 1 minus tan square theta upon 1 plus tan square theta. Also, I should remember this, theta is tan inverse of 2 raised to x. So in the last step, theta will be replaced. So cos inverse of cos 2 theta, which is 2 theta, which can be written as 2 tan inverse 2 raised to x, because theta is nothing but tan inverse of 2 raised to x. So instead of differentiating such a complicated term, just imagine if I had to differentiate this, what would have been my method? Root of 1 upon root of this 1 minus square of this into derivative of that, which will be u by v method. It will be very complicated. Now to differentiate this function, hardly it takes any time for you. The derivative of this function would be, derivative of this dy by dx would be tan inverse u, 2 into 1 upon 1 plus u square into derivative of u. So what will be my answer? What formula did I apply? Just let's recap the formula that we applied. The formula that we applied is dy by dx of tan inverse u is 1 upon 1 plus u square into derivative of u. This formula I have applied over here. So my answer now would turn up to be 2 upon 1 plus 2 raised to x the whole square, derivative of a raised to x. A raised to x log a. Now if you feel like, you can make this into a beautiful answer like this. So 2 raised to x plus 1 upon 1 plus 4 raised to x into log 2. So you can make it this way. 2 raised to x the whole square is 2 square the whole raised to x. They can be interchanged. So it's 4 raised to x. You can make use of that and simplify it further. So this is what you have to understand. Every time sin inverse or cos inverse is given to you, it will match with one of the formulae given here. Use that formulae to find the derivative. Let's look at one more problem. We can create like this hundreds of problems. In place of this theta, in place of tan theta, you can have anything. Now look at next one. Y is equal to cos inverse of, let's say, 3 root x minus 4 x raised to 3 by 2. So 3 root x or x root x I can write. X root x. I can write this way. So it is very difficult for us to identify. But remember one thing, when you have cos inverse outside, have a look at each and every formulae that you have on the left hand side. One of them has got this 3, 4. If you compare this both, you can notice. Just compare this with this. In place of root x, if I have sin theta, I'll be able to apply this formula. In place of root x, if I have sin theta, I'll be able to apply this formula. So I can say, put root x equal to what? Equal to sin theta. So that 3 sin theta minus 4 sin square theta into sin theta. Because x will become what? X root x will become root x the whole cube. So it not automatically will become sine cube theta. So we can replace x root x by sine cube theta. So everything is perfectly matching. So I will be having now root x equal to sine theta, which implies theta is sine inverse root x. So y became cos inverse 3 sine theta minus 4 root x is sine theta, so sine cube theta. It got to match with some of this formula, otherwise you cannot apply this method. So every time you have to look at this and decide what formula to apply. That's the interesting part. So if you have this formula in front of you, you can easily identify every time. So you have to master this formula, then only you will be able to do in this problem. So cos inverse of sine 3 theta, 3 sine theta minus 4 sine cube theta is sine 3 theta. But cos inverse sine cannot be cancelled. So but sine can be converted to cos by putting a pi by 2 before the angle, pi by 2 minus 3 theta. Now cos inverse cos got cancelled. We can write pi by 2 minus 3 theta. Now theta can be replaced by sine inverse root x. So what will be my derivative? So dy by dx will be 0 minus 3 into 1 upon root of 1 minus root x the whole square into derivative of root x. Now I am going to continue. I am removing this formula. We'll discuss this formula later in the next module. So my answer would be 3 upon root of 1 minus x into derivative of root x is 1 by 2 root x, and I can simplify further that you may do yourself. So this is how you have to understand. Look at what is outside. Decide what formula out of this. If sine or cos comes, one out of this formula has to come inside. Then only you can find the derivative. This is the technique that we are going to use in this module. So in my assignment, I'm going to make a lot of problems based on this technique. Looking at the function, you have to look at this how many formulae? 6 plus 2, 8. 8 formulae, you need to look at it and make. That is my first module. My second module will have the tan inverse one. So today's exercise will be based totally only on 2 functions, when outside is cos inverse and outside is sine inverse. Next module, I'll be putting outside as tan inverse and applying the problem. Then we'll have root problems. So we'll have many other, for 2 or 3 modules, I'll make it into this and make you expert in this topic.